Since its inception, Elon Musk and SpaceX have been reshaping the rocket industry with a single audacious goal: Mars colonization. Their belief? Humanity must become multiplanetary to ensure survival. Through advancements like reusable rockets and the Starship, envisioned as an interplanetary airliner, they're turning this dream into reality. However, the creation of a self-sustaining Mars colony is a whole different beast, full of risks and challenges. Can we conquer such a harsh planet? Is the payoff worth the peril? Let's explore. Now, let's take a closer look at the conditions on Mars, which is, to put it mildly, an incredibly hostile environment for humans. There's nothing remotely welcoming about it, and that's our first major hurdle. The thin atmosphere of Mars poses one of the most significant challenges. It's worth noting that the air pressure on the red planet is less than 1% of what we experience on Earth. This implies that humans wouldn't survive outside a pressurized environment. It's a non-starter. Let's also consider the low-pressure situation. Even if we could somehow manage to breathe on Mars, this low pressure would cause our circulatory system to give out in less than a minute, with an average temperature of negative 60 degrees Celsius, negative 76 Fahrenheit. The existence of liquid water becomes physically infeasible on Mars. Water on the surface would freeze solid, and due to the low pressure, the heated ice would bypass the liquid state, transitioning directly from solid to vapor. Another challenging factor is the Martian dust. Mars is infamous for its extensive dust storms that can stretch across vast areas. Approximately once a decade, a dust storm is known to engulf the entire planet. We haven't entirely figured out why this happens, but it's undoubtedly a technological hurdle. Back in 2018, NASA's Opportunity rover was rendered inoperative by a dust storm that covered its solar panels. This Martian dust is electrostatic, making it cling to every surface, and to make things even more problematic, it's toxic. Inhaling this dust could lead to severe lung diseases in humans. Therefore, a thorough decontamination process would be needed for any object entering any potential Mars habitat. Moreover, there's the issue of cosmic radiation. Mars's thin atmosphere offers scant protection against the sun's potent UV rays. We're still not entirely sure about the impact of this radiation on human life over an extended period on Mars. This opens up questions about the potential effects after prolonged exposure, a critical consideration for future colonists. Unfortunately, the pioneers who choose to live on Mars will be the test subjects in this grand experiment. They'll need to come to terms with the fact that exposure to cosmic radiation is an occupational hazard, one that could lead to serious health issues. It's evident that life on Mars won't be a walk in the park. However, with the question lingering, could the Martian living situation potentially improve in the future? We continue to explore. Let's delve deeper into the Mars conundrum. From all the info we've gathered, it seems Mars wasn't always this icy wasteland we see today. It likely had liquid water at some point in its whopping 4.6 billion year history. There's even a chance we could stumble upon fossilized Martian life. This implies Mars once had an atmosphere. So, what happened to it? Can we reconstruct it? Can we make Mars more Earth-like? Here's the thing. When a planet's atmosphere disappears, it could either be soaked up into the surface or get lost in space. Unfortunately for us, Mars seems to have experienced the latter. Solar winds likely whisked Mars's atmosphere away, and this probably ties back to the concept of magnetic fields. Earth's core is a dynamic hub of activity, with tectonic plates swimming on a molten layer surrounding a spinning hot core. This action gives birth to a strong magnetic field that acts like Earth's protective umbrella against harmful solar elements. Mars, on the other hand, is kind of like a big inactive rock. It doesn't have plate tectonics or a revolving magnetic core. As far as we know, it doesn't have a protective shield, at least not nowadays. Over eons, the Martian atmosphere made a great escape into space, leaving the planet barren. Reviving an atmosphere on Mars won't be a cakewalk, and it might not even be possible. But that hasn't stopped the dreamers from envisioning some pretty out there ideas. One such theory involves setting off nuclear bombs in space above the poles to create a mini-sun scenario. This should crank up the heat enough to melt the surface and release greenhouse gases, essentially kickstarting Mars's own version of global warming. But there's a snag. Most of the greenhouse gases that once existed on Mars have already fled into space, not stayed put on the surface. Even if we could liberate all the hidden gases from the polar regions, it wouldn't suffice to pressurize the planet. The consensus among scientists is that the most we could aim for is about 7% of Earth's atmospheric pressure, which isn't really up to snuff. So, If we ever set our sights on Mars, we'll have to grapple with the fact that the planet isn't exactly hospitable. Maybe one day terraforming Mars could become a reality, but it's going to require some groundbreaking invention that we haven't yet dreamt up. If turning Mars into Earth 2.0 isn't feasible, we'll just have to bring Earth's comforts to Mars instead. NASA has already set the ball rolling on this with an experiment called MOXIE, which was carried out by the Perseverance rover. MOXIE managed to convert a tiny amount of Mars's carbon dioxide-rich atmosphere into oxygen. The device, about the size of a toaster, used high heat to split oxygen from carbon dioxide. If we can scale up this technology to sustain a colony, we could be onto something. Elon Musk, SpaceX CEO, has proposed another solution: living under sleek, futuristic glass domes. These domes could maintain a controlled climate and pressurized atmosphere. Still, there are logistical issues to consider, like how to transport construction materials to Mars or set up a dome production facility there. And there's the lingering question of whether the dome material could offer sufficient protection from cosmic radiation. NASA has also floated the idea of 3D printed structures using Martian rocks. In fact, the American architecture firm AI Space Factory clinched the win in NASA's 3D printed habitat challenge with their unique egg-shaped habitat concept. The idea is to mine basalt from Mars, crush it, and mix it with a plant-based bioplastic to form a robust, printable material. An automated robot would then build the structure in layers, creating a habitat that can withstand cosmic radiation and extreme temperatures. While this is certainly innovative, there are still challenges to overcome. Any building on Mars would require a complex airlock system due to the drastic differences in air pressure. Plus, the issue of the toxic Martian dust needs to be managed. We can't have that stuff making its way inside the habitats. It may not sound like the most thrilling option, but living underground may be the safest bet for Mars inhabitants. The surface tasks could be left to autonomous robots, like those crafted by Boston Dynamics or the upcoming Tesla bot. We've gotten pretty good at constructing underground tunnels, transport systems, and bunkers here on Earth, so why not apply that know-how on Mars? Mars settlers might find themselves delving into caves and empty lava tubes scattered across the planet. There, they'd begin building a habitat complex designed as a network of spiral structures, accessed via surface holes and sloping downwards for maximum safety. Construction materials wouldn't be a problem since the accompanying bots would use Martian water and soil, regolith, to create cement. This cement would then be 3D printed or sprayed onto tunnel walls and living spaces to prevent them from caving in. Another crucial aspect of Mars colonization we can't overlook is the need for food and water. For a Mars colony to be viable, it's going to need to be self-sustaining. We know that Mars had its share of water back in the day, with evidence of lakes, rivers, and oceans. It's likely that there's still water hiding at the polar ice caps and potentially beneath the surface, too. Water recycling systems, like those used on the International Space Station to reclaim water from urine and sweat, also be a necessity. However, for a bustling community, tapping into a local water source will be key. Cultivating food on Mars is a trickier beast. One method might involve leveraging Martian soil water and a kind of algae known as cyanobacteria that can endure Mars's harsh conditions. Once the cyanobacteria has a foothold, they'll enrich the soil, laying the groundwork for other plants to flourish. This could lead to a Martian city teeming with greenery, with plants sprouting in tunnels, domed craters, and pretty much anywhere they can take root. Using advanced farming technologies like vertical agriculture could create optimal conditions to yield a bounty of leafy greens, veggies, fruits, and specialty crops like herbs, coffee, and chocolate. Carbohydrates might be in short supply due to the space they need to grow. So Martians might find themselves eating fewer grains, but it's feasible to grow certain types of legumes and grains that could be efficiently produced on Mars. Mars plant life would pull double duty, also helping to provide oxygen, recycle water, and provide raw materials. But raising livestock for food on Mars doesn't seem like a viable option. Instead, the colony could turn to cellular agriculture and precision fermentation for protein production. Precision fermentation uses modified yeasts, fungi, and bacteria to transform starches and sugars from food waste into proteins. Some companies on Earth are already churning out dairy products without cows using this method. Cellular agriculture, on the other hand, involves lab-grown meat from stem cells, meaning Mars colonists could enjoy meat without the need for raising animals. It's amazing. The dream to colonize Mars is massive, bold, and pretty complicated. But don't you find it a little bit thrilling, too? Join SpaceX on this crazy journey. Share your thoughts, and who knows, your ideas might make us all Martians someday. Don't forget to leave a like on this video if you enjoyed it. Also, be sure to comment below with your thoughts on the topic of Mars colonization.